Hey everyone, I'm Sanket Sahu and I'm super excited to talk about how I built a dev server all in the browser. So with no dependency on CLI or running npm run dev, how I imitated the whole thing to run inside the browser. The reason why I built it, because I needed my editor in Rapid Native to actually be very performant and to be very fast as soon as any code changes. I did not want any external dependency or any latency. And here is how I did it. I've asked Rapid Native to create an app for brewing coffee, and it's building right in front of me, and it's doing everything in the browser. The code is being streamed, and as it streams, it's actually seen here on the screen. So ideally, if you have to run a full app or maybe an expo app, you would first clone it, and then probably you'll go ahead and do npm run dev or something like that. But here in this case, everything is happening in the browser. The previous version of the same thing actually used to run a sandbox in the cloud and then used to connect it with the iframe showing that. But here, the code that's being streamed, it's actually running inside the browser. And why I built it, the primary reason was I needed speed. I want this to feel very instant. So as I say, click on the editor and then probably say select a part of this, say discover new brewing coffee, or maybe probably I can select, this one, the brew the perfect cup, right? I can say brew the perfect mug, for example. And you can see that it happens instantly. And this is an actual TSX file with a full-blown editor and have all the files here in the browser. Yeah, this is what I'm going to talk about, how I built the entire rendering that happens in the browser. So right from converting this TypeScript file to a JavaScript file to like request and response. So everything happens in the browser. So yeah, let's get to the whiteboard and see like how a dev server works first. And then the next step would be how I imitated the same thing inside the browser. Yeah, let's go. What happens when you do npm run dev, for example? So when a dev server runs, let's talk about a React app or a React Native or Expo app. So the first thing that any web server needs. So as you do this, it boots up a dev server on your system, which listens to a port. So let's say this is the dev server. And once the dev server runs, it probably starts running on a port. Usually it's like 3000. And so after that, your browser can actually request, say you've got your browser over here, and you can say request to the dev server. And the dev server then responds with probably the first response is usually an HTML file that the browser can understand, say index.html. And then index.html can again request, say, external resources, like say it can request for, say, the bundle dot, which is like the JavaScript part of it. And then the server responds with bundle, and then the browser like renders it. Similar thing happens on the native side as well inside React Native. So let's take the web server as an example. Dev server usually listens to files, say let's call it FS, a file system, and then it reads them, and then it also runs a build step. So this is FS, and then FS has like the code can be, say, in the src folder. This gets converted to, say, a dist folder. So we can have the source, and this is where you make changes in your code editor. So this is what you do in the code editor. You directly make changes to code inside the app. So it can be the entire app folder, and then you have like usually the src folder or something like that. And then it gets built into a dist folder. So yeah, and you code here. So the developer interaction happens over here with the code editor. And yeah, so this is how it happens. And then the dev server runs something called a watcher on top of it. And then it writes into a dist folder where usually the bundle exists. And so yeah, the request directly goes from here back to the dev server and back to the browser. Watcher actually watches the file system, and it keeps like building dist folder. And the build process happens in something like, okay, so we have got a build step. So build is a complex process that happens. So it usually takes .ts file and converts it to .js file. Then we have say tsx file that gets converted to .jsx, or even that gets converted to .js, something like that. And then we have external dependencies that are patched on top of it as well. So the code will have something like node modules where external dependencies are injected. And so we have got the users files. So build step is over here, and then we have got the user files, something like this. And then we have got node modules as external dependencies. These things are sometimes bundled. So if we are using expo, then this gets bundled into, say, bundle.js. Essentially, these two combine. And this bundling happens with the Metro bundler. So Metro bundler actually does two things. It also transpiles all the source file that browser does not understand, like TypeScript, TSX, JSX, converts them into .js, and then bundles them into something like a bundle.js. And then that's served through the dev server, and then the browser actually renders your app. So this is a typical setup of how a dev server works. Now, to achieve what I just showed you, if you want to, say, do something like a code editor over here, and then you want to change it to, say, Rapid Native, and this is instantly changing things, this entire process has to happen inside the browser. So the question is, does browser have the APIs that can probably imitate a dev server? Does the browser have something like an FS, which we can watch, and can we actually run the entire build step inside the browser? The answer to this is yes, and that's what I have done in the whole Rapid Native toolkit. So let's talk about each of these pieces one by one, and then we'll see how we can imitate the same thing. We need something in the browser, a browser native API that can actually help us respond to requests. And this has to be a network request. So we have something called service workers that actually intercepts all the request and response that to any particular link or any particular server from the browser. So service worker is a piece of code that we can install for a particular domain name in the browser, and all the requests that goes outside of that particular environment, if the browser makes any request, it has to go via it. We can route that request via service worker. So service worker works as an interceptor or as a proxy layer. Service worker was mainly introduced to build PWA or give an offline first behavior to web apps, and that's why service worker was introduced. I've used the same concept and augmented service worker to behave like a dev server. So instead of having it run on a different port, what I've done in Rapid Native is like anything that has this prefix like _SW, and anything after that is actually responded by the service worker. Yeah, so the dev server is replaced by a service worker, and I'm not like watching all the requests. Any request that starts with _SW and anything after that is actually handled by the service worker. That's the first piece. Then we had to imitate the file system, and for that what we created is, we call it VFS, virtual file system, and there's a simple key value pair in the JavaScript object which has like files, folders, and essentially it imitates how a file system would work. And yeah, this gets replaced by this, where we have also added things like you can create, say, new VFS, and then on top of this we can say VFS is equal to new VFS, and then after that we can do VFS dot add file, remove file, or maybe even watch, where we have a callback function. And yeah, so against the source file we have created an object of VFS, and we call it like source VFS. And then we have got the dist, and we call it the destination VFS. With the help of watcher, we are actually watching it and trying to like build the source files whenever there's a change and pass it to dist VFS. That happens with the watcher that I just explained. And then it goes via build steps. So the basic conversion of .ts to .js happens via the standalone package that we can load in the browser. In the watch step itself, we use Babel standalone. And then we have node modules. So it's very hard to like load node modules in the browser. So this part is replaced by something called esm.sh. esm.sh is a service that takes any npm package and converts it to ES module, which is a browser native way of importing dependencies in your JavaScript file. So all these node modules packages are served from esm.sh. You can do something like esm.sh/react@19, and then you can actually use React inside your app once you do it. Although esm.sh does not support the packages of React Native, so we have created we have forked esm.sh and we call it esm.rapidnative.com. And then you can do something like, say, expo linear gradient, which is not directly supported by esm.sh because the React Native libraries are shipped to npm, but they are like shipped not transpiled. So like JSX would stay as JSX in the React Native packages. And that's why we had to build esm.rapidnative.com by forking esm.sh. So yeah, this is what we did to bring in modules, node modules into the browser. And there's a lot more happens on esm.rapidnative.com. For example, we automatically resolve web.js files whenever there is .web.js file because we are targeting browser, and it does not load any native modules even if there is one. And we also have the first index.html where we have a concept of import map with ES modules, where we have also mapped any import of React Native automatically gets changed to React Native web, which is a nice library and used by most of the Expo projects wherever we have any React Native dependency. I'm just scratching the surface on the architecture level. So if I have to color code it, then probably the red ones that you see. And then we have got these things in this one. These files are also persisted in a browser native database called IndexedDB. Any change that is made, I think this is called OPFS. I mean, there's an alternative file system in the browser. I guess it's OPFS. Let's see. OPFS browser. Okay, so yeah, it's called OPFS, which is a browser native FS as well. Although we have not used it, but we may end up using parts of it when we want to handle assets and blobs. So yeah, if I have to say how I mapped the working of a dev server in the browser, the first one was the requests go to service workers instead of a dev server, and it's prefixed by _SW. And then instead of the file system, we have created a JavaScript class called VFS, which is a virtual file system that gets synced to IndexedDB, which is a browser native API. And then we have source and destination, and there's a watcher in the VFS that actually transpiles everything from the source to the destination in the dist folder. And service worker actually uses files from the dist folder. It involves a build step. So all the TypeScript conversion and TSX conversion is transpiled using the standalone package in the browser. The node modules does not exist. It directly is mapped to esm.sh. This whole architecture is very similar to Vite because there is no bundling. Metro bundles everything into bundle.js. But with the use of ES modules, we directly use everything unbundled in the browser. There's another interesting piece that I missed talking about was about how React hot module reload happens inside Rapid Native. We have used something called React Refresh. This is used by most of the React apps out there to perform an HMR, hot module reload. And we update in the build process, we also add the signature of the module. And whenever any change happens in the watcher, it notifies the browser that, okay, this particular file has changed. So when it actually writes, it also notifies the browser saying, okay, that there's a change. And yeah, then browser again requests that particular module and then reloads it. So this was very difficult to implement. We had to go back and forth with the signature and making sure that particular module is requested by the browser and replaced at the runtime without causing like any scroll or stutter or any refresh sort of thing. Yeah. And the code here is actually Monaco, we call it. So this is a Monaco text editor, which is a part of the VS Code ecosystem. So that's what I've used. We have not used the complete VS Code editor. We've just used Monaco and then created everything on top of it. Because running VS Code in the browser takes a bit of memory and it's more complex than just getting a Monaco editor. So yeah, the code editor is like the Monaco. And we are going to like slowly add more things. Currently, the TypeScript files that we have does not show types. That's probably the next step, how we can use a web worker to actually run so probably it'll happen over here, which is not there yet. So web worker will run the TS server where the type definition would get generated from the source code. So yeah, this is how I have implemented the whole dev server of Expo in the browser. So service worker instead of the dev server, instead of the TS server, we are going to introduce a web worker and run the TypeScript type server there. Instead of the file system, we have created something called VFS. And then we have got the editor, which is replaced from VS Code to a part of VS Code, the Monaco editor. The build step, there is only transpilation happens. There is no bundling that's happening currently. So transpilation of .ts, .tsx files are all happening with the Babel standalone package. And instead of bundling everything, we are using ES modules, which is a browser native way of dependency injection. And we're just using this. So this whole structure is also very similar to how Vite works. And yeah, along with the VFS, we are now currently working on, I'll just mark it as orange, which is called Lightning FS. This is a brilliant project which actually came out of something called Isomorphic Git. So this is a browser native Git implementation that we are working on, that we are using. And then with Rapid Native, we are also going to have a browser native Git integration with no server again. So everything, even the undo, redo, and all timeline is currently being maintained in Isomorphic Git in VFS. And all these files are also stored on our server. VFS is actually synced to an actual database via API calls. But yeah, it does not need to be. It can all stay in the browser if we don't need any persistence. So yeah, these are the upcoming things. So Git integration is coming in Rapid Native, which is happening on top of VFS. And then we have got TS server, although there's a complex part, but yeah, this is how we can also achieve typing in the browser. So yeah, this is the whole setup. Replaces the whole web server in the browser. And the reason why we did it, because we want to make Rapid Native really fast and probably have a lot of design features coming in, which like as you drag and drop or resize things, it should update the code instantly without a full back and forth with an actual dev server. So yeah, that's how I built the dev server in the browser. Thank you so much.